Welcome to the video tutorials of mechanisms by mekanizmalar. The steam turbines are so essential for our daily life, yet most of us don't know there is such a thing as a steam turbine. They are everywhere, but away from public view. And they are not like giant wind turbines we see on the hills when we are traveling on country roads. If you see one in close-up, it is not very interesting, since everything is hidden in a case. However, they are engineering marvels if you know how they work. All power plants, based on converting heat to electrical energy, use these turbines. Nuclear-powered submarines or aircraft carriers use them. There are many different type steam turbines, and one way or another, they overcome a specific problem for their existence. If weight and size are your concern, one ingenious steam turbine invented by Ljungstrom brothers is your solution. Considering advancement humans made in manufacturing, it would be relatively cheaper to manufacture. The turbine consists of two turbine discs with a number of concentrically arranged blade rings fixed on each disc. The blade rings of one disc run between the blade rings of the other disc in opposite direction. The live steam enters at the center of the turbine and passes through the blade rings radially outward. In short, the steam flows from the center to the periphery. Although there are no fixed blades, the blades of one disc act as guide blades for the steam going to the blades of the other. It is seen that the relative velocity between blades and guide blades is twice as high as would be the case if one set were stationary. Therefore, the work done in each blade ring is 4 times as great. Consequently, due to the moving guide blades, only 1/4 the number of blade rings will be required to develop the work ordinarily obtained from the steam. This accounts for some of the saving in weight and space claimed. The steam enters at the center of each turbine disc, which is practically identical, inside of the innermost blade ring through a number of holes in the hub of the disc. As the steam increases in volume by expansion, the length of the turbine blades must be proportioned to meet this increase in volume. The cross-section of a pair of turbine discs with blade rings showing this blade proportioning would appear as shown. Ljungstrom turbines have been used steam locomotives successfully. However, diesel and electric locomotives replaced old steam locomotives which could start working immediately without waiting for boiler to produce steam. And also, they were less complicated and easy to maintain. These turbines rotate with high rotation speeds. However, due to wagon wheel effect, I kept rotation speed low. Notice that all the blue blades have same rotational speed. The same is true for the green blades in opposite direction. Notice that when I begin the increase rotation speed, due to wagon wheel effect, strange things will begin to happen. Such as some green blade rings will be rotating in opposite direction. Or some blue blades on a ring will stand still, the other blue rings rotate. To understand this phenomenon, I suggest you watch my video about wagon wheel effect. Thank you for taking the time to watch our video. If you enjoyed this video and found it to be useful, please subscribe to my channel and hit the like button. We appreciate your support.